First-order circuits are too simple, which can only play a limited role. Since this lecture, we will introduce second-order circuits. Generally speaking, the second-order circuit is a circuit consisting of two energy storage elements. When the two energy storage elements are capacitor and inductor, their energy can be exchanged between each other. You will soon find out that the exchange of energy will bring very interesting phenomenon. Before starting the formal introduction, we also need to learn the solution of the second-order linear ODE with constant coefficients. Let's review the first-order ODE. The first-order ODE can be divided into two cases. One is a homogeneous equation whose right side of the equal sign is 0. Another is an inhomogeneous equation whose right side of the equal sign is a function with t. We review the homogeneous equation first. We assume that x equals a times e to the power of lambda t, so the derivation of x equals a lambda a times e to the power lambda t. Substitute these two into it. We know that lambda a times e to the power of lambda t plus 2a times e to the power of lambda t equals 0. Because a times e to the power of lambda t can be eliminated, so we got that lambda plus 2 equals 0. That is, lambda equals to minus 2. So that's x equal a times e to the power of minus 2t is a general solution of the equation. Of course, if we want to find the underdetermined coefficient a, we need to give the 0 initial condition of the equation. For example, x0 equals 2, substitute it into the expression. We know that equals 2 when t equals 0. So the solution of the equation is x equals 2 times e to the power of minus 2t. After the homogeneous equation, the solution of the inhomogeneous equation can be divided into two parts. The part x prime is the general solution of the corresponding homogeneous equation. According to the above derivation, we know that x prime is a times e to the power of minus 2t. X double prime is a special solution. It should be written based on the form of the terms on the right side of the equation, such as for t squared, we have to assume that x prime equals to bt squared plus ct plus d. So dx prime double prime dt equals to 2bt plus c. Substitute these two conditions into the equation. Through comparison the coefficients of t squared, t, and the constant term, we can get b, c, and d. We know that x equals to x prime plus x double prime by adding the two solutions. Here a is a underdetermined coefficient. By using initial condition, such as x0 equals 2, we can get a, so the whole solution for the equation is completed. This is the process of the first order. For the second order, the special solution is the same as the first order. So we put more focus on the general solution of the homogeneous equation. We'll give three examples. The first example is shown in the figure. Similarly, we still assume that x equals a times e to the power of lambda t. So dx over dt equals lambda a times t e to the power of lambda t. And d squared x over dt squared equals lambda squared times a times e to the power of lambda t. Substituting the three expressions into the equation on the left, we know that lambda squared times a times e to the power of lambda t plus 3 lambda times a times e to the lambda power of lambda t plus 2a times e to the power of lambda t equals 0. Because all a times e to the power of lambda t can be eliminated, we get the characteristic equation that is lambda squared plus 3 lambda plus 2 equals 0. It is a quadratic algebraic equation about lambda, which is different from the first order. We can solve it by the method of completing the square. That is like this way. So that's the expression can be factored easily. That is lambda plus 1 times lambda plus 2 equals 0. So its two roots are lambda 1 equals minus 1, lambda 2 equals minus 2. So a e to the power of minus t and b times e to the power of minus 2t are general solutions of the equation. If we want to complete the solution for a second-order ordinary differential equation, in addition to the equation, we need two other conditions. That is the value of x0 and the value of dx dt when t equal to 0. So we usually write x equals a times e to the power of minus t plus b times e to the power of minus 2t as a form of a general solution of the homogeneous equation. This is the form of the general solution for the homogeneous equation when the algebraic equation has two different real roots.